Hey everybody, this is Mr. Dan with Touch Technologies, and today we're going to continue on a series of YouTubes on Sheerpower. In this particular case, we're going to be talking about using Sheerpower to build a very cool game using Sheerpower clusters, in particular what are called cluster arrays. And here we go, making a Riddle Me This game. So this will be little riddles that'll happen. And let's see exactly how we're going to do this. So Sheerpower cluster arrays can act like a spreadsheet. Sheerpower takes advantage of this by providing a really cool way to load spreadsheets directly into a cluster array. Millions of rows can be added per second, so it's really efficient. Our game is not going to be quite millions of rows. We're going to have a few thousand. We have a spreadsheet called Riddles with two columns. The first column is the question. The second is the answer. And let's just take a look at that real quickly. Here we go. Here's our question, and here's an answer. I get wet when drying. I get dirty when wiped. What am I? A towel. Really simple. Okay, but there's thousands of these riddles in this riddle spreadsheet that we have, and we'll be using this for a particular little game here. So how do we use it? Well, we have a cluster called Riddles, not surprising. There's a question, and there are answers in it. We're going to be using what's called a cluster input statement in Sheerpower, which is specially designed to load in CSV files and other kinds of delimited files. We're going to be providing the name of the spreadsheet file, the number of column headers to skip. We have one column header. If we take a look here, again, we'll see we have one column header here. And the name of the cluster received the data. The syntax is cluster input, name, and riddles.csv. There's one header, and we're going to load it into the riddles cluster, which you see here, riddles cluster. Okay. Sheerpower is a size function that gives us the number of rows that are in a cluster, so we can get the number of rows when we need to. And then we can start by printing out something that says we have, and then the number of riddles, and then tell us the number of riddles. So that's our first step in this. Okay, very nice. So where are we so far? Well, we've defined our riddle cluster, we've loaded riddles into it, and we've shown how many riddles we have. And here's the code so far. Cluster riddles, here's the question, answer, room for those. We do the cluster input, we grab from the CSV file, it's got one header, load it into riddles. Number of riddles is the size of the riddles cluster that we built, and then we have so many riddles. Okay, so that's what we have so far. So let's try that, see how we're doing. Here we go, cluster riddles, cluster input. I'm going to run this thing. We're going to stop right here after we load the number of riddles. Run it. We have 2,664 riddles, so that'll be pretty fun. We're going to choose them at random too in this game, so it'll take a while before someone learns all the riddles, that's for darn sure. Okay. How do we do all this thing? Well, we're going to choose a random riddle, we're going to display it, and then we're going to wait for an answer. We have an R&D function in Sheerpower that generates a random number between 1 and the number of riddles that we have. And then there's a set cluster statement that'll be used to establish that particular row in the cluster table. And then we're going to use a function called a wrap function. You can see it right here, which word wraps it all so it looks really pretty, and you give it left and right margins. And then we're going to input the asking the user for the answer. And you can see here, set cluster riddles, row, R&D's random, number of riddles, grab the question, grab the answer, print out. We're going to wrap with a margin, left margin of 5 or right margin of 70, the question, and then we're going to grab their answer. So that's what's going to be happening next on here. Okay, so let's just take a look at doing that. And here we go. So we're going to run this. Take a look at it. Okay, answer, their answer right there. Run this. If you drop me, I'm sure to crack, but give me a smile and I'll always smile back. Well, I actually don't have any idea what the answer to that is, but we don't care for this little demo. It says try again. Let's print the answer just to kind of cheat here. And the answer was a mirror. If you drop me, I'll crack. Yeah, that's a mirror. If you give me a smile, I'll always smile back. Very true for a mirror. So that gives you an example of one of these riddles. Pretty cool. Next step. So now we have our random riddle, as you noticed. We did that by doing a set cluster row, number of rows thing. We got the question, we got the answer. We wrapped it, we asked for their answer. Next thing we do is we're going to compare to get a score. And if we take a look here, how that was done, there's a compare function. You give it an answer, you give it their answer. It gives you back the likelihood that the two answers are the same, the answer and their answer match. It says, great, you got it right, or, you're on the wrong track, or whatever, try again. So that's how this particular code works. So our game works, but it's hard to guess those answers. You can't really know what they are very easily. We're going to need some clues. We need to have a bunch of answer clues to do that, and that's going to require a little bit more coding. And what we're going to do in this thing is that we're also going to clean up our code a little bit and set up some routines. The use of routines allows us to write our code like we're telling a story. Sheerpower routine names can contain an underscore. And we're going to be writing what's called a public routine. A public routine has access to all the variables in the main program. It's designed to be called from only one place in the code. Its job is to declutter code. Okay? That's what a public routine is used for. It's going to be using a string function called the left function, which returns the leftmost number of characters in a string, and use a repeat function to repeat a string given number of times. We have a routine called handle answers. It's going to start an index number from 1 to the length of the answer. We're going to slowly show more of the answer and less of these little stars here. So at first we're going to show the first letter of the answer, and then we're going to show a bunch of stars, and then we're going to show the first and second characters of the answer, and then show a few less stars, and eventually we're going to be showing no stars. All we're going to be showing is the answer. So this way it progressively kind of reveals the answer to the user. And now we're going to try that code and see how it works. Here's our code again here. Handle answers. Here's our handle answers code, just like we just showed you. Index equal 1 to the length of the answer. Here's our clue. We're going to ask for the answer. We're going to compare their answer. If they get it right, we're going to say they got it right. Otherwise, we're going to give them more of the answer until they finally get it right. Let's run that code. Here we go. Poker, potato, paint, chocolate. Ooh, I don't know what that would be. The clue, it starts with a C. Poker. Oh, they're all chips. You got it. Yay. Okay, so there we go. We figured it all out. Great sort of thing here. Let's take a look and see what happens next. Our game is starting to be pretty fun to play right now, so now it's a good time to make some public routines out of each of the elements. The reason you do this, just as a general coding practice, is you want to make your program into small little routines so that when something goes wrong, you don't have to think about the program doesn't work. You can think about it in terms of loading riddles doesn't work, or choose one riddle doesn't work, or handle answers doesn't work. So it allows you to encapsulate chunks of code into these little routines, which I've done here. And here's a version of it, of the Riddle Me This game. You say Riddle Me This, version 1.0. Here's our cluster riddles, question answer, load the riddles, choose one riddle, handle the answers, and we just loop and keep doing that. Below are the first two routines that we wrote to tell our story in the code. So as we further enhance the game, we'll write more routines and call them when needed. So here's our first routine, load riddles. It's just like the code we had seen before, but now it's encapsulated into a routine. End routine, it loads the riddles CSV file. It then grabs the number of riddles. It says we have, however many riddles there are, and that's all it does. The choose a riddle routine chooses a random riddle for us, random, given the number of riddles, gets the question, gets the answer, prints it out nice and pretty. And last but not least, here's a routine that handles the answers, gives all the clues. Later we'll call other routines. We can do scoring, we can provide ways to quit, we can write out the scoring information to some kind of database. We have lots of things we could do with this, but that's not what we're doing now. This routine is called handle answers. For 1 to the length of the answer, we again show the clue, ask for their answer, we compare it. If they get it right, we say you've got it, and otherwise we just keep showing it to them. Eventually, if they can't figure it out, we move on to the next clue. And that is how it works. So pretty cool little routine. Let's go run the whole thing here again, just so we can see how it works. Again. Okay, you're a sore loser. You're often called the sour variety of this fruit. Those are sour grapes, I think, right? But let's say it's definitely grapes. Grapes. And, oops, grape. Oh. Grape. And I got it. So perhaps we should give them partial credit for getting grapes instead of grape, but we don't. We could enhance the program to do that. So in general, it's pretty easy to write a little game with Sheerpower, loading up a big array of information that the CSV file that we had could have had 1,000,000 rows on it, and it would have loaded just about as fast. Sheerpower can load somewhere around 5 million rows per second. So it's very, very fast at doing these kinds of operations. And thank you very much.